Hi, I'm Lorenzo from ISTI-CNR in Italy. This is a short presentation of our CVPR 2024 paper dealing with the evaluation of open vocabulary object detectors in fine-grained understanding. Recently, we have moved from closed set detection to open vocabulary object detection. Open vocabulary detection means models can recognize objects defined at inference time, offering more flexibility. However, these models struggle with fine-grained attributes of objects, such as colors, materials, or patterns. How can we quantify this problem? In our work, we propose a benchmark suite to evaluate fine-grained open vocabulary detection. We started with a detection dataset containing structured descriptions of objects' attributes and parts, like the PACO dataset. Then, we used a large language model to convert these structured descriptions into natural language sentences for the detector's vocabulary. We began with the correct caption, called the positive caption. Then, we created alternative captions by changing specific attributes with incorrect ones. We call these negative captions. We use this set of captions as input vocabulary for detectors. Models need to locate objects based on these complex descriptions and accurately identify their attributes. We built two groups of benchmarks. The first group is based on difficulty. Difficulty is defined by the number of attribute substitution in the negative captions. In the hard benchmark, we change only one attribute. In the medium benchmark, we change two attributes. In the easy benchmark, we change three attributes. We also have a trivial benchmark where negatives describe completely different objects. In the second group of benchmarks, we only change a single attribute of a specific type in the positive captions. For example, we change only one color attribute. We do the same for other attributes: material, pattern, and transparency. We tested state-of-the-art open vocabulary detectors on our benchmarks. Here, on the y-axis, you can see the mean average precision of the models. On the x-axis, you can see the number of negative captions in the vocabulary. Models detect objects correctly without negative captions, but they struggle when there are more fine-grained negative captions. This does not happen in the trivial benchmark, because it lacks fine-grained differences. This suggests the main problem is correctly classifying attributes, not just localizing objects described by complex natural language. Among the attribute types we tested, colors are the easiest to discern, as they are more frequent in common datasets. We also report the median rank of the correct caption across all detected objects in the benchmark. A rank for a prediction is obtained by sorting the vocabulary by descending scores and recording the rank of the correct caption. We introduce this metric because MAP only considers the top label. Instead, the median rank shows the confidence of each detector in predicting the correct label among all choices. For example, in the hard benchmark with 8 or more negatives, even top models place the correct caption third or lower for half of the objects. Our study highlights and measures the limitations of current open vocabulary detectors in fine-grained object understanding. No existing method clearly outperforms others. We hope our contribution encourages further research in this area. Thank you for listening. Please visit our website for resources such as code, the paper, and benchmark data.